Welcome back. In previous lecture, we observed that the analysis of CE amplifier. In that analysis, we derived input impedance, output resistance, and voltage gain using transistor equivalent circuit, small signal transistor equivalent circuit. And also we solved one problem. Now let us see the analysis of CE amplifier including the emitter resistor. RE. Let us see the diagram including the emitter resistor is like this. Nothing different to the previous circuit, only the resistor RE is added between the terminals emitter and ground. As usual for the analysis, it should be represented in the small signal model. But here I am not considering the LE effect because its value VA is almost infinity. Therefore R0 is infinity. That's why I am considering it as an open circuit. So this part of the area represents the transistor equivalent circuit in terms of current source value in beta, that is beta IB. Whereas the position of RE is same between emitter and ground. This is the emitter and ground RE resistor in the between emitter and ground. Since the DC sources are zeros, that is they are treated as short circuit, therefore the R1 resistor comes in parallel with the R2, whereas the collector resistor is connected between the terminal collector and ground, and as usual the voltage source with the RS. Now here the input resistance is looking at the it means before the biasing circuit, output resistance is after RC, right? Okay, as usual, first of all, first it is better to derive input impedance. Okay, input impedance is or input resistance looking here. Okay, input resistance is looking here. So if you look the circuit here, what is it should be? It is a parallelly connected a resistor of value R1 parallel R2, and another resistor is RIB. RIB is a resistor here. Okay, here this is the position where RIB is. Okay, RIB include both RPi resistor and RE resistors. That's why here it is RIB. Okay, and when you look the resistance value from this position, the circuit is a parallel connected two resistors. One is R1 parallel R2 and another one is RIB. Okay, therefore the input resistance RIB equal to, or RI equal to R1 parallel R2 parallel RIB. Okay, now let us see what is the value of RIB. Okay, for that, RIB is defined as Vin divided by IB. Vin divided by IB. RIB equal to Vin divided by IB, where Vin in the diagram, if you observe, the input voltage, that is the drop across the voltage between R1 and R2, or this is the voltage between the RIB, right? So Vin is IB into R pi plus the drop across RE. What is the drop across RE? Here two currents you can observe in RE. One is IB current and another one is beta IB current. Therefore Vin you can written as, or you can write as IB R pi plus IB plus beta times IB into RE, right? Therefore if you simplify this equation, IB are cancelled, hence RIB becomes like R pi plus 1 plus beta times of RE. Are you clear? The Vin equation, take IB as common and the numerator IB, denominator IB are cancelled. So the rest of the circuit is R pi plus 1 plus beta times Re, right? This is the RIB. Then coming to voltage gain, okay, output resistance, okay, output resistance is same. To find the output resistance, Vs should be 0, therefore Gm Vgs equal to 0, hence the output is you have RC component, therefore output resistance R not equal to RC. The output resistance are not equal to RC. Clear? You see your diagram. See the diagram, the equivalent circuit diagram. Since Gm Vgs equal to 0, that is current source 0 means it acts as a open circuit. Therefore the output resistance, if you look at the output resistance, only one component is there, that is RC. That's why R not equal to RC. Now coming to voltage gain, the voltage gain AV equal to, as usual, V0 divided by Vs. Okay, here V0 is the drop across RC only. Okay, the drop across RC only. That is, the drop across RC is minus beta IB into RC. Okay, the drop across RC, that is the output voltage, which is equal to minus beta IB into RC. Now substitute this V0 in the voltage gain equation. So V0 is minus beta IB RC divided by Vs. Okay, then separate the terms like minus beta RC into IB means Vin by RIB. IB is, you can write as Vin by RIB into 1 by Vs. Already in the previous slide we have seen that Vin by RIB is equal to Vin by RIB means, that is let us see, write the equation for Vin in terms of Vs. Write the equation Vin in terms of Vs. If you look at the input side, Vs source, Rs resistor and Ri impedance, Ri resistance, suppose Ri resistance. Those two resistors connected in series with the voltage source Vs. Therefore Vn equal to Ri divided by Ri plus Rs, right? Into Vs, of course. Therefore that is, you can write, see here, Vn equal to Vs into Ri divided by Ri plus Rs. If you substitute this equation here, the Vs can cancelled. Therefore the voltage gain is minus beta RC divided by RIB into Ri divided by Ri plus Rs, where RIB is R pi plus 1 plus beta times of Re. Already we derived previously. Okay, so this is the voltage gain for the CE amplifier, including the Re resistor. Okay. So when you include Re resistor, what is the advantage is the input impedance is increased. That is, better performances for the amplifier you can get. Okay, that is the importance of including Re resistor. In the biasing circuits itself, we have seen what is the advantage or what are the merits of including Re resistor, right? Now let us see a problem with reference to this analysis. Okay, one more is, if you see this equation here, usually the input resistance, just now I said that the input resistance is very high. Therefore, since Ri is far greater than Rs and 1 plus beta Re is far greater than R pi, then the small signal voltage gain approximately considered as just minus RC divided by Re only. Okay, if you take this values, if you consider these values, that is Ri is far greater than Rs and 1 plus beta Re is far greater than R pi, therefore the voltage gain is given as minus RC divided by Re. Okay, now let us consider one example problem. the example problem, including same consider same CE amplifier with emitter resistor, and the values are beta is 100, VB is 0.7 volts, VA is infinity. VA, I said already, no, VA is infinity, ICQ is 2.16 milliamperes, VCQ equal to 4.81 volts. Okay, by taking these values, the voltage gain, input impedance and output resistance are calculated, and you may get the values like this. Input impedance is Ri not represented here, Rib represented 41.6k. Okay, Ri also there, Ri is 8.06k, AV is minus 4.53, and R naught not written actually, capital R naught. Capital R naught is equal to RC. Okay, RC. The values already in the amplifier diagram, you can take R1 value is how much, R2 value is how much, RC value is how much, like that. Right, like that you can solve the problem with reference to CE amplifier, including the emitter resistor. Okay, you have to practice daily solving all these problems. Okay, of course, plotting the equivalent circuits, derivations, and solving the problems you have to do every day using calci. Otherwise, it is very difficult to remember these analyses and problem solvings. Why? Because many circuits are there. In every circuit, the same type of analysis and problems you can see. That's why daily you have to practice. Right? Thank you.